Recording started.
All right, so this is going to be the recording for our first test, which is going to be next week. I can't remember what the date was, but I'll have a check later on. Anyways, guys, I should have mentioned, though, that this stuff in the beginning, it's good to print this stuff out, because we're going to go over these exponent laws, these power laws. And what I would actually do is print these out and just have them up on your wall so you can see them like all the time. And that sort of thing just really helps when you're viewing stuff over and over again. Okay? Oh. Okay. Can everybody else hear me okay? Okay, so Aiden, you can hear me okay? And Nolan, you can? Okay, Matt, you can hear me okay? All right. Okay, that sounds good, Nolan. Ah, that's too bad. Okay, that sounds good about the laptop. So, guys, I think what we'll do then is we'll just get started, and Ariel can catch up on this stuff we missed later on. Hopefully she'll be able to get on soon with the laptop there, or the main laptop she was talking about. So, guys, we're going to go over these laws here. And so I was just showing in the beginning what the 6 laws are. I think there were 6 of them. And so if you guys just want to print out this first page, I'll send it later on again. Sorry, there's 7 of them in all. And so you guys can do that later on. But first I'll just go over a quick review of these laws, okay? So the first law is called the product law. You guys might remember from earlier math that a product is the answer to a multiplication question. Okay, so if you have 4 times 5 equals 20, 20 is the product of 4 and 5. Okay? So what the product law says, you can see here that when you have 2 powers with the same base being multiplied, you add the exponents to get the answer. Okay, so you can see here that the exponents are 2 and 3, and you can see we're adding them together to get 5. Okay, so does that make sense, guys, so far? Just stop me at any point if anything's not making sense. Okay, we're just going to go over these quickly first of all, and then we're going to get right into using them. All right, so the second one is called the quotient law. The reason it's called the quotient law is that a quotient is the answer to a division question. Okay, so you can see here we've got a to the 5 divided by a to the 3. And so what we do, you can see here that it says that we get the answer by subtracting the exponents. So we subtract 5 minus 3, and we're going to get a squared as the answer. Okay, so that's the quotient law. The next one is called the power of the power law. Okay, so why is it called the power of the power law? Well, basically you've got one power inside another power. And before I go into this anymore, I just want to review quickly what the parts of a power are. Okay, so we'll just focus on a to the 3. That's a power. That's an example of a power. Now, do you guys remember what the a part is? What do you call the a? What a is? What part of a power is a? Does anybody know? Okay, I think, Matt, did you get disconnected there? Okay, so, all right, so A is the base, right? So the base is the part of the power that gets multiplied over and over and over again. So if we're talking about A cubed, that just means that A is multiplied 3 times, okay? And you remember that the 3 is the exponent, right? Okay, so those are just the 2 parts of a power. So I'm not going to go into that a lot, but just a reminder about that. Okay, so that's the exponent. All right, so the power of the power law, the reason it's called that is because a cubed is a power, right? But it's part of another power, because a cubed is like the base of another power. So because it's like the base, what this really means, a cubed to the exponent 4, it means a cubed times a cubed times a cubed times a cubed. In other words, multiplied 4 times. Okay, that's what the 4 tells us. So does that make sense, guys? And the way that the power of a power law works is you get the answer by multiplying the exponents. Okay, so before we saw we were adding them with one law, subtracting with another. This time we're multiplying them. Okay, so we multiply the exponent inside the bracket times the exponent outside the bracket, and so here we get 3 times 4 equals 12. Okay, so that's the power of a power law. The next law, excuse me, is called the power of a product law. Okay, so why is it called that? Well, first of all, you apply each sorry, I got a cold here, guys. Apply each of the terms in the product. I'm sorry. Each of the terms in the product to the exponent of the power and multiply these 2 new terms. Okay, so we apply the exponent to each of the terms. So a gets squared and b gets squared, right? And so then the answer is a squared b squared. Okay, so that's what the power of a product law. All it means is you take the exponent and you put it on each of the terms, whether they're numbers or they're variables, doesn't matter. Okay, so that's the power of a product law. The next one is the power of a quotient law. Okay, similar idea, but in this situation, you've got a fraction inside brackets, or you could look at it as a division, right? It could be a divided by b written out with a divided by sign, right? But again, it's the same idea. Each one of the variables or numbers or whatever gets the exponent. So a gets cubed and b gets cubed. Okay? So a similar idea to the last law, and that's the power of a quotient law. And just kind of looking at how this one plays out, you can see that if this one was 2/3, oh, there's Ariel. Hey, Ariel. Are you able to hear me now? Awesome, right on. Okay, so what we're doing, Ariel, if you just want to catch up later on the other laws, just watch the beginning of the recording. We just went over the first couple laws. We're going over this one here, which is the power of a quotient law. And so I'm just showing how, with this law here, you get 2/3 raised to the exponent 3. And so both the bottom, the top and the bottom, are going to get raised to the exponent 3. So you can see it's 2 to the 3 over 3 to the 3. And 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So that shows how you'd actually use this and then simplify it. Okay? So again, we're going over these fairly quickly, and then we'll be kind of using them in some questions. Good stuff. Okay, zero law. This one is the coolest law because it's so easy, right? So it's simple. Anything to the exponent 0 equals 1, right? So 3 to the 0 equals 1, 29 to the 0, whatever this number here is to the exponent 0 equals 1. And even this here, you might remember from the lesson, chicken burger to the 0 equals 1. Or maybe that's submarine to the 0 equals 1. Okay, so anything to the 0 is 1. Too easy, eh? All right. And you can actually prove why that's true as well. So the last law here, guys, this one sometimes throws students for a bit of a loop. Once you practice it over and over, it's not too bad. So basically, a power with a negative exponent is equal to the reciprocal of the power. It should say the positive power. So basically, the positive power, instead of a to the negative b, would be a to the b. But because it's the reciprocal, you turn it upside down. You make it 1 over a to the b. So in other words, if it was just a to the b, it would be the same thing as a to the b over 1, right? But we're switching a to the b divided by 1. We're taking that fraction and switching it upside down. So we do two things again. First, we make it a positive exponent. Then we take the reciprocal of it. So we divide 1 by that. Okay? So that's all there is to the negative exponent law. It just takes a bit of practice, right? So going on to the next screen. So we're going to check, guys, and see if you guys have a handle on these. So the first question here, z, that should be z to the 8 divided by z. So I'm just showing it could be written in 2 different ways, right? So do you guys remember what the name of the rule is, the exponent law that we would use to solve this one? I know it might be hard to remember the names of all the laws, and that's why I meant to get you guys to print them out beforehand, and I apologize for not mentioning that. But can anyone remember what this one is called? If you can't, that's okay. Because I know there's a lot of names. Okay, so remember, when we're dividing, that's a quotient, right? A quotient is the answer to a division problem. So this one's the quotient law, and I've just got it written out again here. So again, with that one, we're subtracting exponents, right? And so here we're going to subtract z to the 8. You guys remember that z by itself is really the same thing as z to the 1, right? So what do you guys think the answer would be for this one? Z to what number? Since we're subtracting exponents with the quotient law. What's the answer going to be? I know you guys know this. Okay, who's going to be brave? It's just z to the 8 minus z to the 1. What does that give us? Z to the 7. Right on. Thanks, Aiden. Okay, so that's all we do, right? We subtract. Too easy? You guys are maybe thinking these are too easy, right? Okay, question number 2. Which rule do you think we use for this one? Do you remember what the name is? Okay. All right, so this one, we're going to use the product law, right? Because we're multiplying two things together. All right? And you guys know what the answer is going to be? What's the exponent going to be? Look at the example. Okay, it's going to be 10, right? We're going to add 6 plus 4. Good stuff. All right, so it's going to be minus m to the 10. Good stuff. All right, next one. Which rule are we going to use here? Or at least, what are we going to do? What kind of math operation are we going to do? Are we going to subtract the exponents, add them, multiply, divide? What do you think? Multiply, that's right. Because with this law, I'll just bring it up here. This is called the power of a power law, right? Because this here is a power, part of the other power. We always multiply the exponent inside the bracket times the exponent outside the bracket. Okay, good stuff. This one here, oh, sorry, I just got another. Okay, another student just told me she's not able to log in. So we'll just get her to watch the recording. All right, so this one here, guys, same deal as the last one, right? We just multiply the 3 times the 2. The only difference is we have a minus r as the base. So it's going to be minus r in brackets raised to the exponent 6, right? 3 times 2. Okay, I just wanted to show you something just slightly different with a negative base. All right, so again, power of a power law. Good stuff. Okay, we're going to get into some more challenging ones in a bit. For this one, it says simplify and then calculate. So I just wanted to point out the simplify part means use the exponent law, right? So we're going to use the exponent law, which is going to say that we add the exponents when we're multiplying bases. Okay, so we're going to have minus 3.1 to the exponent 8, right? Okay, so then it says calculate. So what you do as far as calculate is you just press on your calculator, you're going to press 3.1, and then you should have a button there that's a plus minus button. You guys all have that on your calculator? So it just changes a 3.1 into a minus 3.1? Okay, good stuff. So you just take that minus 3.1, and then you should have some button that looks like y to the x, or something like that. You press the y to the x button. That tells you you're going to input an exponent, and then you're going to write 8 as the exponent, and then you press equals. And when you do that, you should get 8,528.9. Okay? So give that one a try. If you don't have your calculator handy now, give it a try later on, and make sure that you can get 8,528.9. Okay, but again, it says simplify, and the simplify part means use exponent laws. The calculate part just means, use your calculator to find out what number this actually is. Okay, so moving along, this one here, again, I think you guys probably are onto this stuff now, so this will be the quotient law, right? And so we're going to divide, or rather we're going to subtract the exponents because we're dividing. So we're going to subtract 6 minus 5, and we're going to get minus 4 to the exponent 1. And we could write our answer as just plain minus 4, right? Because we don't have to write the exponent 1. Okay? So I'm just kind of moving along more quickly here because I think you guys are onto these. Okay, so that shows the math. Okay, here's an example, guys, of a question where you have to use one law and then another law. Okay? So first of all, we're multiplying exponents. So again, we need to use the product law, where we're first of all going to add the 3 plus the 5. Okay, so we're going to get minus 4 to the exponent 8. So we'll show that on the next screen. Okay, so you can see how we went from step 1 to step 2, right? We added the exponents. And now, because we're dividing, we're going to subtract the exponents, right? We're going to subtract 8 minus 5, and we're going to get 3. Okay, and I don't think I showed that, but it's going to be minus 4 to the exponent 3. So does that make sense, guys? Just a matter of deciding which rule to use first. Okay? All right, and again, stop me at any point if you need to, okay? All right, so here's some stuff that's a little bit more, applying what we know and a little bit more meaty stuff. This question says, what's the value of x in this equation? And so, first of all, I just want to point out that when you're multiplying two things, you're going to multiply number times number. So that's why we got 2 times 6 is 12. And then we're going to multiply whatever the power is times the power. So what do you think the x would be? What missing number is there? So remember, we're choosing A, B, C, or D. Sorry, Matthew, did you mean D for this one? Okay. It's small, eh? Okay. Oh, there we go. Hey, Hannah, how's it going? Looks like you're able to get in. Good stuff. So it wasn't letting you in the beginning, eh? Oh, that's too bad. Well, hey, welcome. So, yeah, if you just want to check out the earlier stuff, Hannah, in the recording, and we just kind of went over the a review of the exponent laws. Okay? So some people were saying this was coming up a little small on their screen. It could be because I've increased the resolution on my screen quite a bit, so it didn't look so small. So maybe I should have made it a bit bigger. Can you guys basically see it though? 2a to the exponent minus 3 times 6a to the exponent x. And I'm sorry, guys, I'm going to have to run real quick and just let my dog out because she's whining here. I'll be back in just a sec. Sorry, guys. You could just feel free to chat. Dogs these days, eh? Yeah. Yeah, we got a little golden retriever, only she's not so little now. We got her just a few months ago. She's still 4 months old. Her name's Caramel. So anyways, she wanted to go outside. And now she's happy. You guys have any pets? Got a whole bunch? Oh, no way. Oh, I'm so sorry to hear that. That's too bad, Nolan. Fat and small, eh? Well, hey, I would like to see your dogs. Maybe we could kind of compare notes, you know, we could send out pictures of our dogs, eh? That would be cool. 175 chickens. We had 175 chickens. No more, hey? They're in the freezer now. 120 cows. Wow. Good stuff. Okay, guys, we're just going to get back to this here. So you guys can basically see what it is, right? Can you? So again, I apologize if it's small. So it's 2a to the minus 3 times 6a to the x. And so basically we're trying to figure out what this x is. So we've got, if we just kind of focus on the part of it, it's a to the minus 3 and a to the x. So the x is going to be, like Nolan and I think also Matt said, it's going to be 18, okay? Because if we, just a sec, I got to decrease something here. Okay, so can you see here, guys, that if x was 18, right, then you're going to have minus 3 plus 18, which is going to be 15. Just like Nolan says, subtract 3 from 18. You're actually adding minus 3 plus 18, but it becomes subtraction in the end, like Nolan said. Okay, so does that make sense, guys? So we'll move on to the next one. Again, please stop me if you need help with anything. Okay, so the next one says the following expressions are examples of powers right in order from smallest to largest. So I'm just going to go through this with you guys, and can you see this one okay? Okay, this one's a little more clear, eh? Maybe I'll try to make them a little larger next time. Again, I've got a big screen resolution, so I could see that it could look smaller on some people's. So I just want to make some points here, guys. 2 to the exponent minus 2. You know, what does that mean? Well, for that one, we would use the negative exponent law, right? Which means we're going to have the positive exponent, so it's going to be 2 to the 2, but then we flip it upside down, so it's 1 over 2 to the 2. So that's 1 over 2 to the exponent 2. Okay? So what's that going to be? That's going to be 1 over 4, right? Okay? Now the next one, it's got a negative sign there, but the negative sign is not part of the bracket. So we'll see a difference between the second and third one. What this really means is that only the part that's inside the bracket gets squared. So what we do is we take the 2 and we square it, and then we make the answer negative. So it's 2 squared, which is 4, and then we make the answer negative. So this one's going to be minus 4. Okay? The next one, though, the minus is inside the bracket. So it really means minus 2 times minus 2. And minus 2 times minus 2 is the same thing as plus 4, right? Because when we multiply negative times negative, we get positive. Okay? So this one's going to be 4. And then the next one, it's going to be minus 2 to the minus 2. So what we do here is we take 2 to the minus 2, and what is that? That's 1 over 2 to the 2, right? Okay? So it's 1 over 2 to the 2. In other words, 1/4, and then we make that whole thing negative. Okay? So it's going to be minus 1/4. Okay, so I just thought this was a good question to bring out some different important points about negatives and how they relate to exponents. Okay, so like the difference between number 2 and number 3. And so then if we wanted to write them from smallest to largest, you can see how we do that, right? That would be pretty simple for you guys, so I won't even do it. Okay? But that's just to bring out a few important points about negatives with exponents. All right, so we'll go to the next one. All right, this one here has to do with using your calculator to solve order of operations. And I actually meant to kind of introduce the order of operations first of all, so I'll do that fairly shortly here. But just as a review, when you're doing it on your calculator, basically what you want to do is find a way to input the stuff that's on the top of the fraction into your calculator, and then put the divided, so the division symbol on your calculator, and then put the stuff that's on the bottom, input it into your calculator. So how do you do that on your calculator? Well, what you do is you put brackets around whatever's on the top, first of all, then you do the division symbol, and then you put brackets on whatever's on the bottom, and that will tell the calculator, first of all, find the answer to what's on the top, then divide by the answer to whatever's on the bottom. Okay? So the answer to this one then is going to be brackets around the top. So it's going to be this part here, brackets around the top, divided by brackets around the whole bottom. So you can see I've got brackets around the whole bottom, right? And the bottom already has some brackets. So we're just basically adding 2 brackets on either side of it. Okay? So these are the keystrokes you'd use on your calculator, and that would then give you the correct answer. So does that make sense, guys, how we use these brackets to tell the calculator what to do? Okay. Is everybody else clear on this one? Right on. You guys are swift. Grade 9's rock. All right. So on to the next one. This one here says, which of the following powers is equivalent to the expression above? So the way we would do this one, guys, we would take the 2 to the 3 times 2 to the 4. We're going to use the law that tells us that we add the exponents, right? So far we're going to have 2 to the 7, right? Then we know that when we have a power inside of brackets, and which is part of another power, right, we're going to multiply the exponent that's inside the brackets times the one that's outside. So since we add 2 to the 7 after simplifying, we're going to multiply that 7 times 2, and we're going to get 14. Okay, so far we've got 2 to the 14. I'll just write that down. Okay, 2 to the 14 so far. And then on the bottom, we're going to have 2 to the exponent 5, right? Okay, so we're going to have 2 to the 14 over 2 to the exponent 5. And so what do you think the final answer is going to be? Okay, remember when we're dividing? Okay, I see somebody's typing it out. When we're dividing exponents, we're going to subtract. When we're dividing powers with the same base, we subtract the exponents, right? Okay, so it's going to be 2 to the 9, like Hannah said. Does that make sense to everybody? Okay, right on. So, next one. So we got a few on this page here. This one I think is a fairly easy one. So what do you guys think? Which of the following expressions represents the multiplication there that you see? B. That's right. Yep, it's going to be B, because that just tells us we multiply minus 5 times itself 4 times. Good stuff. Okay, next one. What do you think minus 3 squared equals? Which one of those? Okay, this one's a tricky one. This one actually would be answer C, because in order for it to be 9, it would have to be minus 3 in brackets squared, because that tells us we multiply minus 3 times minus 3. But if you just have minus 3 squared, it tells you make the 3 squared and then put that answer negative. So in other words, make it 9 and then make it minus 9. Okay, so can you see why this one then is answer C? Oh, is that right? Okay. So for 13, does it make sense that the answer is C then? It's going to be minus 1 times 3 squared? Cool. Okay. This one, oh, sorry, we've got a few more. Some of these I think are maybe too easy, eh? So this one here is going to be this here, right? 12 to the 6? Okay. How about this one? Just a quick review of the parts of a power. The 2.7, is that the exponent? Is that a power, quotient, or base? Yeah, the 2.7, that's the number being multiplied by itself 4 times. And the 4 is the exponent. Okay, another easy one here. Really easy, but just wanted to review it. Okay, anything to the exponent 0 equals 1. Awesome. All right, we're just zipping through these here. Okay, how about this one? What do you think that equals? Now you need your calculator, just a hint for this one here. Anybody want to take a stab at it? Okay, so 512, it is 512, but is A true as well? Sorry, I think I'm getting ahead. Okay, now A would be true, right? Because it's 2 times 4. Remember, 2 times 4 cubed means the same thing as 2 times 4 times 2 times 4 times 2 times 4, right? If you're doing order of operations, you do have to simplify what's in the brackets, but this is also a true statement, right? Because 2 times 4 to the 3 says whatever's in the brackets gets multiplied by itself 3 times, right? So it makes sense that it's, you know, brackets times brackets times brackets. Okay, so this is a true statement, right? But then you can also use the law that says that the 2 gets the exponent 3 and the 4 gets the exponent 3. So C is also true. But also, if you take 2 times 4 and make it 8, and raise 8 to the exponent 3, you'll get 512. So they're all true, okay? But they're using kind of different laws, or different kind of ways of understanding exponents, okay? So it's going to be D. Yes. Okay, so does that make sense for everyone? All right. Awesome. Okay, so for the next one, guys, we've got 2 squared to the exponent 3. Yeah, you bet. We're just going to move on, but just catch up with us when you're done with your sets, okay? All right, so this one here is going to be, we're going to multiply the 2 inside the brackets times the 3 outside the brackets, okay? So it's going to be 2 to the 8. So we're going to need to use our calculator and figure out what 2 to the 8 is, or we're just going to multiply it a whole bunch of times. I think that's equal to 64, right? And we know that anything to the exponent 0 is 1. So 2 to the 8 is going to be 64. Sure. Okay, 64 plus 1. So it's going to be 65. So does that one make sense, guys? Okay. I think we just got a few more of these. Does anyone else want to go get a drink or something like that while Hannah's getting her calculator and Nolan's checking on his sister? Yeah, 65 is an option. Again, I apologize. I should have made it larger text. That's answer B. Answer B should be 65. It might look like 66. Okay? Okay. Sorry about that, guys. Okay, so the next one here. What do you think the answer is for this, guys? Oh, okay. I'm really sorry, guys. Okay, so it says 4x cubed, and that whole thing is squared. So I'll just kind of point out what the things are here, the numbers. Okay, so this is a 4 inside the bracket. So because there's an exponent 2 outside, that gets applied to the 4 inside. Remember, everything on the inside gets whatever the exponent is. Doesn't matter if it's a number or a variable. So 4 gets squared, and that becomes 16. So we know it's answer A or C. But then we have a 3 is the exponent inside, a 2 is the exponent outside. We multiply exponent inside by exponent outside, we get 6. So it's going to be 16x to the 6. All right? So it's going to be answer A, like some of you guys have been saying. Okay, so I just noticed somebody's... Oh, you need to finish camp packing, eh, for camp? Okay, that sounds good, Ariel. Thanks for coming. And I'll see you at camp. I think most of you guys have either went to camp last year or coming this year, right? That's cool. All right, take care, Ariel. Have a good one. Bye for now. All right, so we'll go to the next one. Okay, and again, I'll try to go by these ones quickly here. So here, we're going to have 20 squared. Remember, 20 is going to be squared and minus 4 is going to be squared. So 20 squared is going to be 400, right? Minus 4 squared is like minus 4 times minus 4, so that's 16. So this is going to be 400 over, did I say minus 16? I hope I didn't. It should be 16. Okay, so when we divide 400 by 16, we get 25. Okay, so this one should actually be none of the above. Okay, and I don't think I have too many more of these to go. This one here says, okay, can you guys see question 21 okay? It says the power written as a single power with a positive exponent. Okay, you can see it okay? Okay, so how are we going to write this power as a single power with a positive exponent? Well, what we do is we just kind of take 3 to the minus 3, we make that into a power with a positive exponent, and then we deal with the 3 that's on the outside of the brackets. So 3 to the minus 3 is like 1 over 3 to the 3, right? Okay? So that's what's now inside the brackets. We've just used the rule for negative exponent, and we've dealt with the power that we have inside the bracket, the negative power. So that whole thing gets raised to the exponent 3. Okay? So what that really means is we have 1 over 3 cubed times 1 over 3 cubed times 1 over 3 cubed. Okay? So we could write it out that way. 1 over 3 cubed. I won't write it out because it just takes a little bit long to write out. But you could write it out being multiplied by itself 3 times. Okay? When you do that, the ones on top are just going to equal 1, right? Because you have 1 times 1 times 1. And on bottom, you're going to have 3 cubed times 3 cubed times 3 cubed. So you're just going to add those 3's together, right? You're going to add 3 plus 3 plus 3. So on the bottom, it's going to be 3 to the 9. So you're going to end up with the answer 1 over 3 to the 9. Yeah, the test is in a week. I can't remember exactly when it is. I can check my calendar, but it's coming up pretty soon. Okay? So does that make sense how you were able to write this one here as a single power with a positive exponent? How it would be 1 over 3 to the 9? Oh, absolutely. I'll send you guys out the recording, once it's done. I'll send it out in a bit. Okay? Okay, so maybe I will write this one out in longer form, just to see if that helps it make a little more sense. Okay, because Hannah was saying that it was kind of making sense. So I just want to see if this helps a bit, and I'm hoping this stuff's going to show okay on the screen. Okay. So does that make sense so far, guys, what I've done? I've taken this here, because you've got the exponent 3 outside the brackets, that means whatever you have inside the brackets is multiplied by itself 3 times. So I just made 1 over 3 to the 3 times 1 over 3 to the 3 times 1 over 3 to the 3. Okay? And when you do that, you're multiplying 1 times 1 times 1, which gives us 1 on top. You're multiplying 3 to the 3 times 3 to the 3 times 3 to the 3. And so you add these 3's as the exponent using the product law. Okay? So that gives you 3 to the 9. So it's going to be 1 over 3 to the 9. So does that make any more sense now, Hannah? Right on. Okay. So that's that one there. This one here is the question you'll often see on achievement exams and things like that. It's one of those tricky questions, eh? They always like to trick you up and get you to think, right? Okay, so you got to figure out what the x is. Well, if you want to figure out what the x is here, the first thing you can do is you can multiply this 2 times 3, right? And that's going to give you x to the 6. So what that means is you've got x to the 6 equals 4,096. So what that's really telling you is x is just some number, right? So some number times itself 6 times equals 4096. So all you need to do is take it, and in your calculator you can either multiply, say, try one of them out, you know, say 3 times 3 times 3, multiply it 6 times and see if that equals 4096. If it doesn't, you know, try it with the 4. And it turns out that it's 4 in this situation. Okay, so does that make sense how we kind of thought this one through and solved this one? So again, it's going to be 4 times 4 times 4, 6 times, and that's why x to the 6 is 40, why the x is going to be 4. Okay? Just notice Hannah's typing here. Shortcut thing that you can do on your calculator? Well, basically what I would do is, since I'm finding whatever number it is to multiply by itself 6 times, if I was trying 3, I would press 3, I would press the y to the x button, I would press 6, I would press equals, and that would give me 729, so I know it's not 3. Then I try out with, say, 4, I press 4, y to the x, 6, equals, and that gives me 4096. Right? So that's probably the best way to do it, is just using that y to the x function. Okay? Good stuff. So, now we're going to go into BEDMAS a little bit more. Some people call it PEMDAS or something like that. I like BEDMAS. Just kind of reminds me of the movie Bed Knobs and Broomsticks. Okay. If you can't see this too well, one thing I wanted to mention, guys, is I'll send you out the PDF file that I actually used for this, so that way you guys can see the whole thing better on the file later on if you want to go over it later on. Okay? But basically, BEDMAS, again, just says, first of all, the B stands for brackets, so simplify what's in the brackets first of all. Then the E stands for exponents, do any exponents. Then it says multiplication and division, and this is really important. Complete multiplication and division in the order it appears from left to right. Okay, so you need to start on the left, go to the right. And whether it's multiplication or division that comes first, doesn't matter. Whichever one comes first, going from left to right, you do. Same with addition and subtraction. Okay? So once you've done that, you've completed BEDMAS. So I'm just going to go over some here. So with BEDMAS, we start with the brackets, right? So here you can see an example. And so you can see we're starting with the brackets, and we simplify the 3 plus 6 equals 9. So we've got this part taken care of. We have no exponents, so we don't do the E part. Okay? And then we do division or multiplication, whatever comes first. We can see we've got multiplication first, so we do this here. And it's going to be minus 8 times 3 is minus 24. Okay? And then we do the division. So we've got minus 24 divided by 24. That gives us minus 1. Okay, so now we've done division and multiplication, and we're just left with addition and subtraction. So now we do addition and subtraction going from left to right. So we do 9 minus 1 is 8, and then we're left with 8 plus 5 is 13. Okay, so I think this one's a fairly straightforward one, and so we'll just go over another one. This one here, yeah, I wrote up some of the stuff I had already, but some I had to write up. So it's kind of a combination. Now this one here, guys, you remember we do the brackets first of all, right? So we're going to simplify what's in the brackets. And so what we do here is we have 6 plus minus 7, that's the same as 6 minus 7. So I just wrote that, 6 minus 7 minus 1. Okay? That 6 minus 7 becomes minus 1, and we're left with the other minus 1. That gives us minus 2. So now we're done with the brackets. Now that we're done with the brackets, then we can go on to multiplication. Minus 2 times 8 is minus 16. Okay? So I'll go over another one then. In this situation, you've got an exponent. So after brackets comes exponents. So we're going to have minus 1 times minus 1 is going to be plus 1, right? So we write it out as minus 1 times minus 1. That gives us plus 1. And now it's a really simple matter of doing the plus first and then the subtraction. So this one's fairly easy. I probably should have come up with some better examples that had, you know, brackets and exponents and stuff like that. But just wanted to show you a few. Okay, here's one that's probably a little better. This one here has, so first of all, we're going to do the multiplication. So we're multiplying, so we, again, multiplication or division, whichever one comes first. So we multiply -4 times -10, we get 40, right? 40 divided by -2. Yeah, we do brackets. I'm sorry, you're right, Hannah. We need to do brackets first. So the very first thing we did here, we have -9 plus 7 gives us -2. So that's the first thing we did before any multiplication or division. That's the first thing we did. Then we did this multiplication that came first. -4 times -10 is 40. And then we do the division, and we get the answer of -20. I'm glad you caught that, Hannah. I kind of missed that. All right. So I think we might be done the kind of the more basic order of operations I wanted to show you. Just wanted to do a quick rundown on the number systems, okay? And you guys remember the natural number systems? That's kind of the most basic type of number system, right? Just the natural counting numbers of 1, 2, 3. Whole numbers are just natural numbers plus 0. That's all they are, right? We're just adding 0. We're always adding as we go along, adding something new with each number system. So the integers, now not only do we have 0 and the positive counting numbers, we also have the negative counting numbers. Okay? And then we got the rational numbers. Now the rational numbers, you guys might remember, they include a whole whackload of things. So they include everything we've looked at so far. Basically, one way of looking at the rational numbers, any number that can be written as a fraction is a rational number. Okay? So something like -4, can that be written as a fraction? Sure, right? You can write it as -4 over 1. So that can be written as a fraction. 0 can be written as a fraction, right? The square root of 9 can be written as a fraction, right? So those are all rational numbers because they can be written as fractions. And there's also another way of looking at rational numbers. If a number can be written as a terminating decimal or a repeating decimal, it's a rational number. Remember, like 0.125 is a terminating decimal, 0.333 is a repeating decimal. That's another way of looking at what's a rational number. Okay? So just remember that each one of these number systems includes all the number systems before it, plus something else. Okay? So just a quick question then. This one's here. So what do you guys think? Which of the following diagrams correctly represents the relationship among integers, natural numbers, whole numbers, and rational numbers? The symbol for rational numbers is actually Q. And don't ask me why that is. Probably Latin or something like that. So what do you guys think? Which answer would it be? Just going to put it down a bit so you can see them all. Okay, now remember, the rational number system is going to include all the other number systems, right? Okay, so the rational number system, let's try C. Okay, well, let's try C. Well, okay, is the whole number system, is that kind of the most basic one? Well, the most basic one was the natural number system, right? So it's got to be either A or B. And then remember, the whole number system includes the natural plus 0. Okay, so it's going to be answer A. And then the next one is the integers. It also includes the negative counting numbers. And then the rational numbers include fractions as well. Okay, so does that make sense now, guys, why it's A? I know it's just a different kind of a diagram. But once you get onto these, they kind of make more sense. Good stuff. So now I just want to show you guys how to use the BEDMAS or order of operations and apply them to rational numbers. Okay? So again, with this one here, we've got decimals, right? So we're just going to have to simplify what's in the brackets here. We simplify this first one. This one here, remember, if you have two negatives beside one another, that equals a positive, right? Okay, so we've already simplified this part way, and then because the negative number's smaller, or well, it's a larger number, I should say, you end up with a negative number as the answer. So both brackets are actually going to have -3. Okay, so we've simplified the two brackets, and now we multiply. So we multiply these two numbers together, we get 10.89, and then we do the addition. Okay? So just stop me, guys, if any of these don't seem to make sense. But I just want to run through some different order of operations with different sorts of numbers. So here, guys, I'm just reviewing how to subtract fractions. This might be really basic for you guys, but just, with adding and subtracting fractions, remember we want a common denominator, right? Can you use your calculator? Yes, I believe you can. I'll just look at it again, but I'm pretty sure that you can. So just take it as a yes for now, okay? All right. Okay, so guys, we want a common denominator, right? And we want the smallest number that both 8 and 6 divide into. So it's going to be 24, right? Okay? So what we do is we multiply this fraction, both parts of it, by 3 to get 24. And when we do, we get 87 over 24. And we've got 6 on bottom here, so we multiply 4 times both top and bottom. So we're going to get 20 over 24. So we've changed these two fractions now, and we've got 87 over 24 minus 20 over 24, which equals 67 over 24, and then we can change that into a improper or rather a mixed fraction of 2 over 19 over 2 and 19 over 24. Okay? So I hope that's review for you guys as far as adding and subtracting fractions. Just wanted to go over that though. And then I'm just going to go over a few more of these, okay guys? And I think, if I'm not mistaken, I just have to quickly check out and see when the next teacher's session is. Today is Wednesday, right? The next one is 11:45. So we probably have a few more minutes here. All right. So this one here, guys, we want to simplify what's in the brackets here, right? And so what we want to do is we want to take this 3½ and make it into 7/2, because that lets us multiply 3/2 times 7/2 more easily, right? And in this case, we have 6/5 minus 1, and so we make the 1 into 5/5, because it's easy to subtract 6/5 minus 5/5, right? So we're ending up with fractions all around. So we multiply 3 times 7 to get 21, 2 times 2 to get 4. 21/4 divided by 1/5, because it's 6/5 minus 5/5. Okay? So that's what we have to this point. Anybody not clear at this point? What we've done so far? Okay. I'll take that as everyone's clear. Okay, so now, sorry, I'll just let someone finish typing there. 6.5 is like a fraction. Okay, this should be 6/5. This fraction here. We have 6/5, and what I did is I took 1 and I made it into 5/5. So we have 6/5 minus 5/5. And it could be maybe it's not showing up large enough. Okay, so is it making sense, Hannah? Okay, good stuff. So what we have at this point is we have 21/4 divided by 1/5. And remember, whenever we're dividing fractions, we just flip the second one over, so we make 1/5 into 5 over 1, and then we multiply the two fractions. So we multiply 21 times 5, we get 105, 4 times 1 equals 4. So we end up with 105 over 4 becomes 26 1/4. Okay? So that's how we solve these kind of questions. So if you had a question like this, some students might say, okay, well, I know what I'll do. I'll just take these fractions and I'll make them into decimals, and then I'll just, write a decimal answer. But this one, you actually have to solve it, using fractions, okay, and using order of operations. All right, we are getting close, my friends. So, I just noticed no one is typing out something here. Yeah, there's quite a bit of stuff though, eh? I just wanted to go over quite a few different examples so you could get a smattering of different things. And I think it will help when it comes to write the test. Okay, so this one, guys, you know that you want to apply the 2 to both the top and bottom, right? So it becomes 3 squared over 2 squared, and that becomes 9/4. So this is now our new question, 9/4 minus 1 plus 6. And so if we want to add a fraction to some whole numbers, we change those into fractions, make everything a fraction with 4 on the bottom, and we end up with 29 over 4. Oh, sorry, Nolan, did you think I was Mr. Smart? Or are you joking here? I wasn't sure. Do I sound like Mr. Smart? Yeah, you know what? Mr. Smart was the one who set up the Illuminate, and so it just says Mr. Smart for everyone. And it was doing that last year too, and I don't know, it might be Mr. Smart for years to come. You should see when the teachers do their session. It's kind of funny because sometimes we have like 5 Mr. Smarts, and yeah, it's really kind of funny. But yeah, okay. So guys, at this point I was going to talk about square roots, but I'm thinking maybe what I could do is I could just send you this over, and you could just kind of look it over, because I think you know, we've done an hour, and it's probably long enough, eh? So if you guys just want to look over this part, you know, when I send over the PDF file, that it'll just help you a little bit in just reviewing what square roots are about, and just finding the square root of a perfect square. Okay. So so again, guys, please remember your test is next week. We'll have questions similar to the ones we had in the recording here. So I always, you know, like to make it worth your while to come to it. And so I'm just going to check quickly to see when this test is, because I can't remember offhand. Looks like it's on Tuesday, October 5th. Okay, and you can write it any time during the day. Good stuff. Well, guys, thanks a lot for your participation in this. Pi is 22 divided by 7. Cool. Making me hungry here. Yeah, pi is kind of cool, eh? If you take any circle in the world and you measure the distance around it and you divide by the distance across, you're always going to get that number, right? Anyways, how's it being done? Do you mean the test, Aiden? Yeah. Well, basically, I will send the test to your parents, and then they'll download it for you, and then you can just write your answers either on an email or in a Word file, and then just your parents will just send that over to me. Okay? Yeah, some people have calculated pi to incredible numbers. Like they use a computer and they calculate it to I don't know how many decimal places. They take hours and hours. That's right. This one's not self-correct this time. That's right. Yeah, about your mom's username and password, Nolan, I'll have to check into that, okay? Because I'm not sure why she didn't get one. And I'll have to check and find that out for you, okay? And we'll make sure we get that done before the test. All right, well, hey, guys, thanks a lot for coming. And I'll see some of you guys later today, actually, people who are coming to the camp out. And otherwise, hope you guys have a really good weekend. I guess it's a few days away still, but it's supposed to be nice weather, at least here in Edmonton, so. Oh, okay. That's right. I remember that now. You live in Calgary. That's cool. Hey, we won't leave it against you, even if you're we won't have it against you, even if you're a Calgary Flames fan. No, that's okay. No problems. I cheer for the Flames if the Oilers aren't winning. So hey. Oh, is that right? Cool. Right on. Well, hey, yeah, you can leave now, Aiden. Thanks a lot for coming, guys, and we'll talk to you later, eh? Okay, bye, guys.